To a beginner standing at the edge of the pool, the turquoise surface behaves like a heavy, unyielding wall. The immediate instinct is to fight the medium. The body claws at the surface, attempting to climb out of the pool using the same muscular force that works on dry land. This strategy fails because water is 800 times denser than air. Muscular strength cannot overcome that level of resistance through sheer force alone. This calm then build framework illustrates the mandatory bridge between internal state and external skill. Emotional regulation, the EQ layer, must stabilize the nervous system before the physical mechanics of IQ can function. To stop sinking, the swimmer must first stop fighting the environment. Forward movement begins as a negotiation with the laws of physics. Human anatomy is geometrically unbalanced for the water, possessing two warring centers of mass that naturally force the legs toward the bottom. The chest contains the lungs, two air-filled balloons acting as the center of buoyancy. Meanwhile, the lower half is comprised of dense bone and muscle. Swimmers solve this through a technique called pressing the T. By pressing the chest and head deeper into the water, the swimmer uses the lungs as a fulcrum to leverage the hips and heels toward the surface. This requires overriding the land brain, which commands us to lift our faces toward the air for safety. In a fluid environment, that upward tilt of the head mechanically drives the lower body deeper into the pool. Floating functions as an act of geometric alignment. It is the result of surrendering the body's weight to the specific laws of water displacement. Any attempt to move through a dense medium creates an immediate opposing force. This simulation compares two shapes. The brick profile, created when a lifted head causes the hips to drop, forces the water to crash against a vertical wall of skin. This creates a wake of turbulent suction that pulls the swimmer backward. The arrow profile minimizes the frontal surface area. By squeezing the arms behind the ears and pointing the toes, the swimmer creates a tiny hole in the water, allowing the fluid to slice cleanly around the body. In fluid dynamics, speed is expensive. For every doubling of pace, the water quadruples the penalty of drag if the swimmer's shape remains wide or angled. Minimizing frontal resistance provides more velocity than increasing muscular output. Reducing the brakes is the most efficient way to gain speed. On land, we move by pushing against a solid floor. In the water, beginners often attempt to swipe at the surface, as if brushing crumbs off a table. Aquatic propulsion relies on Newton's third law. Forward motion is the direct reaction to pushing a captured mass of water toward the feet. Imagine the pool is filled with thick gelatin. The hand reaches forward and hooks into the medium, becoming a stationary anchor. Back muscles then lever the entire body forward past that fixed point. Slapping the water downward results in an upward reaction, which pops the head up and destroys the streamlined arrow shape. Every ounce of energy must be directed strictly backward to generate forward passage. The arm functions as a stationary rung on a ladder. The swimmer does not pull the water, they pull their body past the water. The panic of suffocation is often a physiological misunderstanding. The burning sensation in the chest is triggered by the buildup of trapped carbon dioxide, not a lack of oxygen. Managing this requires an open exhaust pipe. A steady stream of bubbles must leave the nose or mouth the entire time the face is submerged. Forward momentum creates its own solution for air. As the head moves, it pushes a bow wave upward. Directly behind that wave, a hollow trough of air forms at the jawline, sitting lower than the rest of the pool's surface. The swimmer rotates on a central axis to reach this pocket, the one-eye rule. One goggle lens stays underwater, while the mouth sips air from the trough. This allows for refueling without lifting the head or breaking alignment. The sip of air functions as a synchronized mechanical gear, timed to the precise rotation of the body's momentum. The initial struggle has been replaced by an integrated system. The swimmer now maintains a continuous loop of floating, streamlining, and rhythmic breathing. The swimmer's form maintains a continuous line, allowing water to flow past the skin with minimal turbulence. Each stroke covers more distance with less effort. The water now supports the swimmer's weight entirely. By following the geometric alignment of the lungs and hips, the body moves through the medium rather than fighting against it. This transition from thrashing to gliding confirms the limits of physical willpower in an environment 800 times denser than air. The only path forward is to prioritize alignment over exertion. Efficiency arrives through a quiet, deliberate negotiation with the laws of physics. The water is no longer an obstacle, it is a partner.